and I'm assuming that's started. Yeah, well, I mean, yeah, it came up. Did it come up with a little record symbol? Well, you know, these things, yeah, recording. Cool. I'm assuming a little red dot means recording and not you're about to explode. So after we've done this one, we'll test it and see whether the microphones are all right. But we're doing probability tree diagrams, and we're finally going to record something again. Yay! It's very exciting. Lauren is over the moon. I think she's doing a different subject. Are you doing a different subject? I hate your guts.
I'm ready.
Oh, okay. Yeah, no, that's fair enough. You've been waiting for us because we've been discussing microphone filters,
Exactly.
and I think that's fair. I think you can just, I don't care. No, okay, here we go. So, probability tree diagrams. So, we write the probabilities on the branches, and then we have the final column which calculates the final probability of that outcome. Make sense? So, when we did a normal tree diagram, you had each possible outcome, but you could have multiples, and then at the end you label the sample space or the outcome. Because these have got multiple of the same outcome, that's why we use the probability tree. We label it and we put the probability on each branch, and then at the end we calculate it. So, a more complicated experiment. Or who doesn't love a more complicated experiment? We all love a complicated experiment. All right. A bag contains 6 white marbles and 4 blue marbles. 3 marbles are drawn in succession. At each draw, if the marble is white, it is replaced. If it is blue, it is not replaced. Okay? Find the probabilities of drawing no blue marbles, 2 blue marbles, 1 blue marble, sorry, I went B and C all in the door, and 3 blue marbles. Sorry, mate? That's a very good question. What do you think the probability is that they'll draw a red marble? See, this is a problem. This is why you have a detention, Nathaniel Landers. Who put that up there, by the way? Was that Josh? No, it couldn't have been Josh. You can't reach that high. I don't know who Nathan Landers is. Okay. All right. So we've got to find those probabilities. So what are we going to do first? We've got, I mean, you can already see that I left the tree on there because I'm a nice person. But you've got to put the probabilities in there. So what's the first thing you should do? Yeah, let's just do the basic probability. So what's at the start, when there's all 10 marbles in the bag, what's the probability of drawing a white? 6 in 10. Okay, so that's when all are in there. I think I heard a voice from the other side saying that's 3 and 5. Thank you, voice from the other side. What's the probability of a blue then? We're just going to simplify it straight away. 2 and 5? Awesome. Okay. So those ones, I'm going to go white here and blue there. Okay. So our probability here is 3 on 5. All good with that? And the blue probability would be 2 on 5. All right. So what are the options? Like when you draw, let's say you draw a white. What happens? You put it back. So do the probabilities change? Yeah, if you pull out a white, the next time you pull out another one, yeah, pulling out a white. Okay. So I'm just going to label all these now. So when you pull out a white, because you're putting it back, there is no change to the probabilities because there's still 10 in there. And if you do it again a third time, we're still going to have 3 on 5 and 2 on 5. Does that make sense? All happy with that? Now the other option is that we pull out a blue marble. So if we pull out a blue marble, so we've got 1 blue marble removed, then what? Well, we're going to go 1 blue removed.
There's 6 white.
So the probability of a white would be 6 over 9. What was it? 2/3. And the probability of a blue? We had 4, remember? We just pulled one out, so 3 out of 9, and we'll go with 1/3. Okay. See how not simplifying it straight away can actually make it a bit easier? Because you immediately went, there's 2, but there wasn't, there was 4. Yeah, what's going on? That doesn't add to 10. All right, so if you pull out 1 blue, then the probability of getting a white is 6 or 2 out of 3, and the probability of getting a blue is 1 out of 3. Now, which branches does that apply to? Well, what we've done is we've just gone whites, but now here, this second one down here, we've taken out a blue. It's the first blue taken out. So that means these probabilities are going to be 2 over 3 and 1 over 3. Does it make sense how I got that? Because it was the first blue taken out. And the same down here. We're going to have 2 over 3 and 1 over 3 because it's the first blue taken out. What's our next option? 2 blues removed. So what's our probability of white when there's 2 blues removed? 6 and 8, which equals 3/4. What's our probability of blue? 2/8 or 1/4. I'm pretty happy with that. Everyone else happy with that? Not that I care. So we go and have a look. Where was the second blue pulled? Well, here. So we've got 3 over 4. I've got 1 over 4. What about the ones above that? They're doing different probabilities. They're year 10. Nice. Year 10 probability. What's the probability of getting a head or a tail on a dice? And you watch them struggle. Okay, so what about these 2? There's 2 more that we haven't filled in. What are their values going to be? What you got to think about is what's been taken out. At this stage, you had a blue come out, so you're on the 1 blue removed track. Does that make sense? So on the next one, it was a white. So you're not on the 2 blue track, you're still on the 1 blue removed track. Does that make sense? Yeah, I'm going to assume that Josh is nodding because he agrees, rather than just nodding because he's like one of those dogs you put in the back of the car that's got the bobble head. Meow. Cool. So which probabilities are we using? We're using the 1 blue track, which is the thirds one. So with the white, we got 2 over 3. Apparently we don't. We used to have 2. Oh, there it goes. 2 over 3 and 1 over 3. Everyone happy with that? We've now filled in every branch, which makes me extremely pleased. All right, so now what do? It's asking us for our outcome. So on that first one, what's the outcome? www. What's the next one? Yeah, the outcome rather than the probability. Okay, so there's the outcomes. Now what's the probability? What's 5 times 5 times 5? Yep. So we end up with 27 over 125. What's the next one going to be? It's a 5 times 5 times 5 again. (18 over 125. Next one. 5 times 5 times 3. Huh? Oh, I'm multiplying the probability. Sorry, I should have said. So the first one, we go that one times that one times that one. And then we follow the tree branches. And we just multiply the probabilities as we go along. So I'm now down on this WBW, which means I go up, down, up. So it's 3 over 5 times 2 over 5, which is 6 over 25. which gives us 12 over 75, which can be simplified down to... Yes, that's right, everyone who said it really loudly. 4 over 25. Then the WBB, we've got, once again, it's out of 75, but this time it's 6 out of 75, which can simplify down to 2 out of 25. That's right, you guys are awesome. All right, next one, we're going BWW. So we've got 2 over 5, 2 over 3, 2 over 3, which gives us 8 over what? 45, yes. BWB, so we've got 2 over 5, 2 over 3, 1 over 3. Yep, 4 over 45. Well done. You're doing awesome. It's like arguing with a mirror. 2 over 5, 1 over 3, 3 over 4. I'm not sure he got 72. 5 times 3 is 15, times 4 is 60. Which is what, sorry? 6 over 60, which we would simplify down to. Well done. And last one. 5, 3, 4, so it's over 60. 2 over 60 gives you 1 over 30. All good? So tree diagrams, they can take a little while, but if you're only looking for one specific thing, you don't necessarily have to work out the probabilities of every single outcome. But you can, and that's nice to know. All good?